All right, so hopefully you're getting pretty good with the pH calculations and stuff like that. pOH, we just don't typically do as many examples, so we're typically not quite as comfortable with that. So remember pH, right? Potential of the hydrogen, pOH, potential of the hydroxide. Hydrogen for acids, hydroxide for bases. So a pH scale is really more appropriate for an acid kind of thing, a thing like HCl or HNO3, right? Those types of things are acids, vinegar, citric acid, all that kind of stuff. pOH is really more appropriate for base kinds of things like sodium hydroxide, calcium hydroxide, baking soda, those things with hydroxides that generate hydroxides in solution that accept protons in solution, that kind of stuff. So let's just run through an example problem on one of those. So let's say you have 0.02 moles of sodium hydroxide. I was going to do calcium hydroxide, but that adds in an extra issue of how many hydroxides are. So we're not going to mess with that. So 0.2 moles of sodium hydroxide. Let's dissolve that in 5 liters of water. Dissolves in 5 liters of water. Right? So we want to know the pH and the pOH for something like this, right? So anytime I have a situation like this where I'm worrying about acids and bases, worrying about titrations, anything like that, I want to make sure and get a handle on, is this an acid or a base, right? So with the hydroxide here, this isn't a base. So anything I do as far as log stuff is going to give me a pOH on this. So the calculation for pOH is negative log of the hydroxide concentration. Those brackets mean concentration, right? So that's molarity. Well, molarity was moles per liter. Well, they gave me moles and they gave me liters. So don't make that tough, right? Just like if it's 0.02 miles in 5 hours, right? Well, that's really slow, but you could do that, right? It's just moles per liter. So I'm just going to take, to get my concentration of my hydroxide, my molarity, that's going to be 0.02 moles divided by 5 liters, right? So don't have to, you can use a calculator even, right? 0.02 divided by 5, that gives me 0.004, right? So don't have to make this tough. 0.004. I could either write moles per liter like this, or I could write 0.004 and then a big M for molar. Either of those would be just fine. But that is sodium hydroxide, or in solution, it would break up into ions. It would dissociate, right, into hydroxide ions. Either of these would be an okay label for that, right? There's more than one way to write things. So if I want to get up here to my pOH, I'm just going to do the negative log. Let's go ahead and change colors now. So negative log of 0.004. So that is not too tough to do. I'm just going to do negative log, right? There's your log right there. You got to do negative log and then the 0.004, and that gives me a pOH of 2.4. Right, so my pOH is 2.4. A low pOH is basic. And then remember, pH plus pOH is 14. That's where that scale of 0 to 14 comes from, right? So if I just do 14 minus my pOH, that gives me my pH. So 14 minus my answer gives me 11.6. 11.6, right? So 11.6 is my pH. So that's a high pH. I would expect a base to have a higher pH. I would expect a base to have a lower pOH, right? So one more little practice problem there. Let's actually do one more. I know it's going to make this video a little longer, but let's go the other direction. Let's say we have a pH of, your pH is, you measure a pH, right, with like a pH strip, and it's 3.1. Well, pH strips won't give you 3.1, but a pH meter would. And we want to know, well, what's the H plus concentration then? What's the molarity? If maybe I want to do a titration with that and I need to know the molarity of that. That's the anti-log, right? So that's going to be 10 raised to the negative of the pH. So that's going to be anti-log of negative 3.1, right? So I just hit second log. It's hard to look on here backwards. I hit second log, that gives me the 10 raised to that, and then I have to put in the negative of the pH, And when I do that, right, I'm going to expect to get 3 zeros because that's powers at 10, and then 0.00079. So 0.00079 molar in my H plus. Right, 3 places here plus a little extra. So you get that 0.0079. And I would do the same thing if I wanted hydroxide from a pOH kind of thing, right? They work just the same.